Hello student, good morning. I am Dr.A.J. Sinha, Professor of Chemistry. Today I am going to discuss preparation of nitrogen gas, also called dinitrogen. Last class I have discussed general properties of group 15 elements. Now I am coming individual. Preparation of nitrogen gas means dinitrogen. Dinitrogen is produced commercially by the liquefaction and fractional distillation of air. Liquid dinitrogen, its boiling point is 77.2 Kelvin. Liquid dinitrogen or liquid nitrogen, its boiling point is 77.2 Kelvin. Distills out first, leaving behind liquid oxygen. Liquid oxygen boiling point is 90 Kelvin and liquid nitrogen 77.2 Kelvins. Hence, liquid nitrogen distills first and oxygen will be left out. Okay. Liquid nitrogen distills out first, leaving behind liquid oxygen. In the laboratory, how we will make? In the laboratory, dinitrogen is prepared by treating an aqueous solution of ammonium chloride with sodium nitrite. Reaction you can understand: ammonium chloride liquid aqueous NH4Cl plus NaNO2, that is also aqueous. Both are aqueous. Both will react. Ammonium chloride plus NaNO2, it will form three products: nitrogen gas plus water plus sodium chloride. And in a small amounts, in this nitrogen gas, a small amount of NO and HNO3 are also formed. That is actually impurities. A small amounts of NO means nitric oxide and HNO3 are also formed in the reaction. These impurities can be removed by passing the gas through aqueous sulfuric acid containing potassium dichromate. Means to purify the gas, means to remove the NO and HNO3, what is done? Then it is passed through the gas. Okay. This gas I am talking about, here NO and HNO3 just like impurities. Then to remove these impurities, can be removed by passing the gas through aqueous sulfuric acid, and in that acid potassium dichromate must be present. It can this gas also can be obtained, means nitrogen gas. Other method I am telling you, nitrogen gas also be obtained by thermal decomposition of ammonium dichromate. Ammonium dichromate means NH4 Cr2O7. Just you have to heat strongly. Then this ammonium dichromate breaks down and it will give three products: nitrogen gas plus water plus chromium oxide means Cr2O3. This reaction is very important. NH4 Cr2O7 on decomposition, means thermal decomposition, it gives three products: nitrogen gas means N2 plus 4H2O plus Cr2O3. This is the second method of preparation, but you will get a small quantities. If you want very pure nitrogen gas, then how will you prepare? Now, this is the third method. Very pure nitrogen can be obtained by thermal decomposition of sodium or barium azide. What is the formula for barium azide? Then BaN3 whole 2. BaN3 whole 2. Then on decomposition, means on heating, it will give two product, barium plus 2N2, barium plus 3N2, not 2N2, 3N2. Okay, BaN2 whole 3 is there, and not BaN3 whole 2. Then N3 whole 2 is there, means total 6 nitrogen is there. That's why it will give barium plus 3N2. Now it is a balance, 3 into 2, 6 nitrogen. It was in the beginning, now it is 6. Then barium azide means BaN3 whole 2. It gives barium plus 3N2. This I told 3 method of preparation of nitrogen gas. Now what is its properties? Properties of nitrogen gas. Then actually these things you should know, because this is common gas, nitrogen gas. Nitrogen is a colorless, odorless, tasteless and non-toxic gas. It is not poisonous, non-poisonous gas. Non-toxic, it is a tasteless, odorless, colorless, no color. Nitrogen atom has 2 stable isotopes. You might be knowing, that is 14 and 15. Nitrogen 14 and nitrogen 15. That is both are stable isotopes of nitrogen. Okay, nitrogen 14 and nitrogen 15. It has a very low solubility in water. Very low solubility in water. It is not soluble too much, very low, very less. That is 23.2 cubic centimeter per liter of water at 273 Kelvin and 1 atmospheric pressure. If temperature is normal temperature 273 Kelvin and 1 bar pressure, that time in 1 liter of water only 23.2 milliliter or centimeter cube will dissolve. 23.2 ml of nitrogen gas will dissolve. That is a very less. Okay. And what is about this freezing and boiling point? I will tell you separate. Okay. Further I am telling you, dinitrogen is rather inert at room temperature because of high bond enthalpy of N triple bond is there. Then its bond enthalpy is very high. Okay. Then this dinitrogen is rather inert at room temperature because of high bond energy of NN bond. Reactivity increases rapidly with rise in temperature. It is inert. Despite that, as the temperature increases, reactivity increases. Reactivity increases rapidly with rise in temperature. At higher temperature, it directly combines with some metals. Nitrogens combine with metals to form predominantly ionic nitrides. This reaction is very, very important. Okay, it forms ionic nitrides and with metal and with non-metal, and with non-metals covalent nitride. It forms covalent nitrides with non-metal, and with metal ionic nitride. Okay, just I am telling you just 2 examples. Lithium plus nitrogen. Lithium plus nitrogen gas. Lithium is metal. Then both will react and it will form lithium nitride. Lithium nitride is ionic nitride, Li3N. Li3N. N has 3 negative. Okay, N2 was there, that will, if it will break, then N will have 3 negative. Then 3 negative means 3 positive will come to neutralize. That's why Li3N. Hence balanced equation you can understand 6Li plus N2, and after heating it will give 2Li3N2. Now it is a balance because 6 lithium was there. Now we are getting 2Li3N, means 6 lithium and 2 nitrogen. First example I told you. Now second, that is the 3 Mg plus N2. 3 Mg, Mg is also metal. 3 Mg plus N2. Then you will get Mg3N2. Mg3N2 means what? Mg3N2 means magnesium nitride. Okay. Now I am telling you other reaction. It combines with hydrogen. Nitrogen combines with hydrogen at about 773 Kelvin. Okay, means high temperature. It combines with hydrogen at about 773 Kelvin in the presence of a catalyst, that is what we are telling Haber process, to form ammonia. N2 plus 3H2, many times I told you, N2 plus 3H2 both are gas. It forms 2NH3 ammonia gas. It forms ammonia gas. Okay, temperature I told you, that is the 773 Kelvin. And heat of formation, delta HF, this heat of formation is minus 46.1 kilojoule per mole. Delta H, okay, heat of formation minus 46.1 kilojoule per mole. Another reaction I am telling you, dinitrogen combines with oxygen, oxygen gas, dioxygen also, for oxygen O2 gas is also known as dioxygen, only at very high temperature, about 2000 Kelvin, to form, after the reaction nitrogen plus oxygen, it will form nitric oxide, means NO. Its reaction is very simple. N2 plus O2, both are gas, it gives 2NO, nitric oxide. Okay, this you will get after heating. N2 plus O2, after heating you will get 2NO, nitric oxide. Okay, this I told the properties. Now I am telling you some uses, means application. The main use of nitrogen gas is in the manufacture of ammonia and other industrial chemicals containing nitrogen. There it is, main application is for the manufacture of ammonia and the industrial chemicals containing nitrogen, as for example calcium cyanamide. This cyanamide contains nitrogen. It also finds application where an inert atmosphere is required. If you want inert atmosphere, means that place where there should be no reaction, there also it is used. Okay, where you can say an inert atmosphere is required. As for example, that is in iron and steel industries. In iron and steel industries, inert diluent for reactive chemicals is required. There it is used. Diluent means you want to dilute the any solution. Then nitrogen can be mixed. Okay, as a diluent, you can tell diluent, and nitrogen is inert gas. Then there it is used, means in iron and steel industries, inert diluent for reactive chemicals. Now next application, liquid dinitrogen, means liquid nitrogen gas is used as a refrigerant. In refrigerator, nitrogen gas is used, okay, as a cooling agent, also called as a refrigerant, to preserve biological materials, food items, and in also it is used in cryosurgery, where coldness is required in surgery, then that is called cryosurgery. There also it is used. I have told one reaction that this barium azide, like that way, if sodium azide is there, then what will be the product? Means what will the reaction if sodium azide is heated, NaN3, question is asked. NaN3, if it is heated strongly, then it will give sodium plus some nitrogen gas. Barium azide already I told you. Now sodium azide, okay, it gives sodium plus nitrogen, means balanced equation 2NaN3, it gives 2Na plus 3N2, balanced equation. Actually this question, this reaction has been asked in examination. That's why I have told you a special. Now I am telling you about ammonia, preparation of ammonia gas. Preparation of ammonia gas. Ammonia gas is present in small quantities in air and soil, both places. Ammonia is present in small quantities in air and soil, okay, where it is formed by decay of nitrogenous organic matter. Nitrogenous organic matter gives ammonia gas. Example, urea. Urea, you know, is a fertilizer. Urea. Then this urea, that it after decaying, means in plant it may be present. Then urea, what is the formula? Then carbon monoxide will be in the middle, CO, and both side NH2, NH2. Okay, CO is in the middle, left side NH2, right side NH2. This is the urea. Then urea plus water, it gives actually, first it will give ammonium carbonate. This urea plus 2H2O, means NH2CO NH2 plus 2H2O, it will give ammonium carbonate. Ammonium carbonate means NH4 whole 2 CO3. Correct? Because here you can say NH2 is there and 2H2O is there, plus 2H2O. Then 4 hydrogen and 4 hydrogen already is there, NH2. Total 8 hydrogen. And oxygen became how many? 3 oxygen and 1 carbon. And 3 oxygen, 1 carbon means carbonate. Then now you can write 2 nitrogen is there, then you can write NH4 whole 2 CO3, ammonium carbonate, first it will give, After that, this will decompose and it will form ammonia gas, 3 product. It will form ammonia gas plus H2O plus carbon dioxide gas. This reaction is also very important. NH4 whole 2 CO3. It gives 3 product ammonia gas plus H2O plus CO2. And in a balanced way, if you want to know, then NH4 whole 2 CO3, it gives 2NH3 plus H2O plus CO2. Correct? Then I told you by decaying of nitrogen organic matter, it gives, like urea, it gives ammonia gas. It is present in a small quantity in air and earth, soil. Now, on a small scale, ammonia is obtained from ammonium salts. Okay, if you want ammonia gas in a small quantity, on a small scale, ammonia is obtained from ammonium salts, which decomposes when treated with caustic soda or lime. Caustic soda is what? What is the caustic soda or lime? Then it is a calcium hydroxide, CaOH whole 2. Means that when ammonium salt, like ammonium chloride, when it is heated with calcium hydroxide, it gives 3 product: ammonia gas plus water plus calcium chloride. Balanced equation you can understand: 2NH4Cl plus COH whole 2. It gives 2NH3 plus 2H2O plus CaCl2. And other salt, it is ammonium chloride plus calcium hydroxide, I told you. If you will take ammonium sulfate, then what will happen? Ammonium sulfate, just like ammonium carbonate, it is also ammonium sulfate is the salt. SO4 has 2 minus, carbonate also has 2 minus, sulfate also has 2 minus, and ammonium has 1 plus. Okay. Then now ammonium sulfate, NH4 whole 2 SO4 plus 2NOH. Okay. Then here, that is a soda lime, you can tell here, 2NOH. Then it will give 3 product. Then 2 product is common, what I discussed earlier, means ammonia gas plus water. But here you will get sodium sulfate. In the earlier you got, when ammonium chloride you have taken, then it has given calcium chloride. Ammonium chloride plus calcium hydroxide is given ammonia gas 2NH3 plus 2H2O plus CSL2. But here ammonium sulfate plus NOH, 2NOH, you got 2NH3 plus 2H2O, same way, plus Na2SO4. Correct? Now, if you want in a large scale, ammonia, if you want on a large scale, then ammonia is manufactured by Haber process. Many times I have told you. Means N2 gas plus 3H2 gas. N2 plus 3H2, it gives 2NH3. Just you always remember, very common reaction. N2 plus 3H2, it is giving 2NH3, and heat of formation is minus 46.1 kilojoule per mole. Now here important things I am telling you. In accordance with LECT principle, high pressure would favor the formation of ammonia. Why? N2, I am telling N2 plus 3H2. Here in the reactant, total 4 moles are there. N2 1 mole, 3 mole hydrogen. But product you are getting 2NH3, means 2 mole. It means a condition which will give less pressure, that will be favorable. Then What is the condition? How will you get less pressure? Due to high pressure. If you will apply high pressure, then only volume will be less. Hence high pressure is favorable. Okay, favorable for the formation of ammonia. And what is actually pressure? That optimum condition for pressure. The optimum condition for the production of ammonia are: first pressure I am talking about, pressure of 200 into 10 to the power 5 Pascal. That is roughly you can tell about 200 atmospheric pressure. Both are same. 200 into 10 to the power 5 Pascal. Okay. Or you can tell 200 atmospheric pressure. What about the temperature? Actually condition is asked. Remember 200 atmospheric pressure or 200 into 10 to the power 5 Pascal. Both are same. What about the temperature? Then temperature should be roughly 700 Kelvin. 700 Kelvin, exact is 777. But anyhow, any value you can tell above 700 it will work. 700 Kelvin. And the use of air catalyst you require. In Haber process, catalyst you require. Actually earlier iron was used as a catalyst earlier, and as a promoter molybdenum was used. Only two things, iron and molybdenum, but molybdenum was as promoter and iron was as a catalyst. But nowadays you remember what is going on. Okay, but nowadays along with a temperature pressure you are maintaining, you have to maintain a catalyst. You have to take a catalyst. Which catalyst? Then iron oxide, means FeO. And along with this FeO is used as a catalyst. But if you want these things fast reaction should be fast, means ammonia gas should form fast. Then K2O and Al2O3 is also mixed. Small quantities of K2O and Al2O3 is mixed to increase the rate of attainment of equilibrium. Correct? But earlier I am telling you iron and molybdenum was used. Okay, this I have told you about these things, manufacture of ammonia, Haber process. Okay, actually here in Haber process, experimentally just I am briefing you. You have to take hydrogen gas and nitrogen gas, and that gas you have to compress it. In a compressor you have to send it, and high pressure is required. Pressure I told you 200 atmospheric pressure. Okay, that you have to apply. Then volume will be less. High pressure you applied, and after that what will happen? That this gas will be sent. This gas will be sent to the, you can say, where catalyst is there it will be sent. Means this gas will be, after the pressure, this gas will be passed through the catalyst, like iron oxide, aluminum oxide plus potassium oxide. Okay, there you will pass, and temperature you have to maintain around 700 Kelvin. Then there now because nitrogen and hydrogen you have mixed, then and high pressure you applied, then ammonia gas will form. But along with ammonia gas, nitrogen and hydrogen will be there. Some quantity of nitrogen and hydrogen will be there. All hydrogen and nitrogen is not compressed fully, but this pressure maximum hydrogen nitrogen gas converted to ammonia, but little is remaining, hydrogen and nitrogen. Then now you want to remove this hydrogen and nitrogen gas, then this actually, because it will be high pressure, then ammonia gas will be in a liquid form, okay, that you can separate it, and nitrogen and hydrogen, it will not, you can say this ammonia gas is liquid actually, in high pressure. At high pressure ammonia will be liquefied, then nitrogen in the gas form, it will go outside, okay, means you will be pumped out. Then now liquid nitrogen you got. From the liquid nitrogen you can get the liquid nitrogen itself is a very useful as a coolant, refrigerant. Nitrogen N2 gas is also liquid, can say refrigerant, coolant, and ammonia gas is also coolant. Both are coolant, don't forget. Many times question has been asked. Okay. Now I am telling about properties of ammonia gas. Properties of ammonia gas. Actually, ammonia gas, I told you, nitrogen gas, ammonia gas, these are very common. Hence, you should know these two gases, because always these gases you will need, and in reaction also, many reaction these gases are utilized, and it is useful gases both. And now I am telling properties of ammonia gas, and also I will tell a structure of ammonia. A structure of ammonia. NH3 you know, but what is its structure? I will tell you. Ammonia is a colorless gas, no color, with a pungent odor. Pungent odor means you can't smell. Pungent odor, and its freezing and boiling points. Now I am telling you freezing point and boiling point. Then its freezing point and boiling points are 198.4, this is the freezing point, and 239.7, that is the boiling point. 198.4 Kelvin, that is the freezing point, and 239.7 Kelvin, that is the boiling point. Okay. In the solid and liquid state, again important things I am telling you, which is asked in examination. In the solid and liquid states, it is associated through hydrogen bonds, because many NH3 will be there. Then you know that nitrogen is electronegative element, hydrogen is electropositive. Hence, when many NH3 is there, then they will make hydrogen will make a bond with nitrogen, weak bond, hydrogen bonding, just like water. In water also same thing, H2O, many H2Os are there, then O is electronegative, hydrogen is electropositive. Hence, when 2 H2O, 3 H2O, 4 H2O will come together, close, then there will make a weak bond between O and H, long. You can mention it in long way, because bond is weak. Long means weak bond. Then same way like water, here ammonia also you can say makes hydrogen bond, and it convert to liquid. Actually it is a gas, but it can convert to liquid and solid, because when all NH3 many NH3 will join, its molecular weight will be high. Okay, it is associated through hydrogen bonds, as in the case of water, and that accounts for its higher melting and boiling point. Now you can understand why its boiling point is high. Why it is a melting point is high and boiling point is high, due to the high molecular mass, due to hydrogen bonding. What you were expecting, it is more. Okay, if you consider only for NH3, then that time both are less, melting point and boiling point. But if it is in the solid or liquid form, then its melting and boiling point is high. Okay, the these things, the ammonia molecules. Now a structure I am talking about. A structure, many questions are asked on a structure. Then you remember that ammonia molecule is a trigonal pyramidal. Trigonal pyramidal. I will send the structure. Already I sent earlier. Again I will send the structure of ammonia. Then it is a trigonal pyramidal with a nitrogen atom is at apex. Nitrogen atom will be apex. With this nitrogen, 3 hydrogen is attached. Okay, that is called apex, APEX. It has 3 bond pair. It has 3 bond pair and 1 lone pair. And because of 3 bond pair, it is making 3 bond with hydrogen. And 1 lone pair is there, lone pair of electron. On nitrogen, 2 electrons are there. That is called lone pair because it can donate it to others. Its aqueous solution is weakly basic. Why aqueous solution? Then NH3 plus H2O, aqueous is water. NH3 plus H2O, it forms NH4 plus OH minus. Then due to this hydroxyl ion, it is basic. Okay, and what will be the angle between HNH? Angle between HNH, correct? Then its angle is 107.8 degree. Okay, because 2 hydrogen is making bond with nitrogen, then HNH, 3 you consider, N is in the apex, then its angle is 107.8. And what is the bond length between N and H? Then it is 101.7 picometer, picometer. That I told about the structure. Question is asked about the bond length, about the bond angle, and about the this trigonal pyramidal, what type of structure is there, and lone pair of electron. Then I have told you about this. Now further I am telling you, it forms ammonia salts. It forms ammonium salts with acids like ammonium chloride, ammonium sulfate. Okay, this ammonia gas forms ammonium salt with acid. As for example, ammonium chloride, ammonium sulfate, etc. Okay, they will make salt like ammonium chloride and ammonium sulfate. Okay, and because it is a basic, it is a big base, it precipitates the hydroxides. It precipitates the hydroxide, means hydrated oxides in case of some metals. Okay, or you can say this of many metals from their salt solution. As for example, ZnSO4, that is a zinc sulfate plus ammonium hydroxide. This reaction is important. ZnSO4 plus ammonium hydroxide, 2NH4OH. It gives 2 main products. Both products are very, very important. First, precipitate I am talking about. Metal precipitate, that is a metal hydroxide, means ZnOH2, white precipitate. And other product is salt, ammonium salt, NH4(2)SO4. Okay, then ZnSO4 plus 2NH4OH, it gives ZnOH2 solid, means precipitate, white precipitate, plus NH4(2)SO4, aqueous form, salt. Now like that way, if you will FeCl3, suppose you are taking, this is also salt, FeCl3, ferric chloride, plus ammonium hydroxide NH4OH, FeCl3 plus NH4OH. It gives Fe2O3. Hydrated and water molecules is hydrated XH2O. You don't know how many X is there, maybe 2, 3, 4, 5, 6. Okay, then that is called hydrated oxide of ferrous. Then it gives FeCl3 plus NH4OH. It gives Fe2O3 XH2O plus ammonium chloride, means NH4Cl, aqueous. Okay, and this will be precipitate Fe2O3 XH2O, that is the brown precipitate. Question is asked, color of the precipitate. This is a common reaction. You might have seen in lab also, or if not, then you will see if you will go to the lab and will do the experiment. Now I am next properties I am telling you. The presence of a lone pair of electrons on the nitrogen atom of the ammonia molecules makes it a Lewis base. It donates the electron pair and forms linkage with metal ions, and the formation of such complex compounds finds application in detection of metal ion such as copper and silver. Suppose you want to know that in any solution copper is there or not, or silver is there or not, then this lone pair of electron plays a big role. Okay, the presence of lone pair of electrons on nitrogen atom of the ammonia molecules make a Lewis base. It donates the electron pair and forms linkage with metal ions, and the formation of such complex compounds finds application in detection of metal ions such as copper ion, cupric ion and silver ion, Cu2 plus and Ag1 plus. Okay, then Cu2 plus 4 NH3 reaction I am telling you. Suppose in solution cupric ion is there, Cu2 plus, and you have dissolved in, you can say ammonia, liquid ammonia you have dissolved or aqueous. Then Cu2 plus 4 NH3. Here you should know Cu2 plus, its color is blue. Always cupric ion color will be blue. But if it will form complex, then it will form which type of complex? Then CuNH3 whole 4. CuNH3 whole 4. And 2 plus will be there. Upside 2 plus will be there. Okay, because it is forming complex compound. Then CuNH3 whole 4, 2 plus. Okay, because ammonia is a neutral ligand and Cu has 2 positive charge. That positive charge is showing in the product CuNH3 whole 4. Ammonia went to the vacant d orbitals, and there is not affecting the charge. Charge is as it is. That's why it is giving 2 positive charge, and its color is a deep blue. Means blue became deep blue. Then deep blue color tells about that copper is present in the solution. Like that way, silver ion plus chloride ion, it gives silver chloride solid, and this silver chloride solid means AgCl plus 2NH3. It forms complex AgNH3 whole 2. AgNH3 whole 2, and only 1 plus will be there. That's why Cl will attach, 1 Cl. Then you will get complex compound, that is AgNH3 whole 2 Cl. Okay, whole 2 Cl. This is actually colorless. Silver precipitate, AgCl is white precipitate, that precipitate is reacting with ammonia and it is giving colorless silver ammoniate. Okay, AgNH3 whole 2 chloride ion. Okay, Cl will be outside because it is a complex ion. Then this I have told about the this ammonia. What is actually application? What is application? Means use, that I am telling you. Ammonia is used to produce various nitrogenous fertilizers. You might have heard the name nitrogenous fertilizers. Example of nitrogenous fertilizers. Then first example is ammonium nitrate. Ammonium nitrate is used as a fertilizer. Second, urea. Third, ammonium phosphate. Fourth, ammonium superphosphate or sulfate, you can tell. Ammonium sulfate. Then ammonium phosphate and ammonium sulfate, also called superphosphate, ammonium phosphate. It is fertilizer. Then ammonia, 4 fertilizer I told you. First, ammonium nitrate. Second, urea. Third, ammonium phosphate and ammonium sulfate. Okay. Then as a fertilizer it is used. And in the manufacture of some inorganic nitrogen compounds also, here it is used. The most important one being nitric acid. Nitric acid, in preparation of nitric acid also ammonia is used. Liquid ammonia is also used as a refrigerant for the cooling purpose, you know. Okay. Then I have discussed about the this two can say this nitrogenous compound I discussed. First I have discussed nitrogen. Second I discussed ammonia. Okay. Today I am stopping only here. Next class I will discuss different oxides of nitrogen. That is very, very important. Many questions is asked on oxides of different oxides of nitrogen. Okay. Thank you.